Hello grade 12s, welcome to my channel and I hope this finds you well. Today we're going to discuss some more NBT related questions, this time focusing on some measurement. This was by request by Miss Abrahams and I hope she will be watching and enjoy the video. And I do hope and believe that it will answer some of the important areas she probably wanted to have sorted, and also the onlooker here may also find something meaningful. If not, do comment on the comment section and perhaps place your requests, or look into the channel and find on the description of the channel there is my email address, so one can easily email me the questions they need me to look at. Alright, so let's just start off by looking at some few questions and see how far we go. So we're going to start with this question 79. Alright, so first of all, before we just jump into the questions, it is important to understand these few things. With measurement, since we're not using a calculator, it's very important to understand long division, which is a concept taught mostly in grade 4, 5 through grade 6, okay? And then long multiplication, which is taught also heavily through grade 6 to 9, and some basic addition and subtraction, which is stuff from grade 1 to around grade 4. Obviously, this is me trying to remember some grades where this was a thing, you know? And obviously with the basic addition and subtraction, we need to understand the organization of digits or numbers in terms of their thousands, hundreds, tens, and units. Units being single digits. And also some formulae, okay, are very important for area, volume, and perimeter. So let's start with question 79. Now question 79, we are given here that a water sprinkler is placed in the center of a square field and rotates to water a circular area. Okay, now if the sprayed water just reaches the four sides of the field, question is, what fraction of the field is not watered? So obviously this is an indirect question, more like a hybrid question. So for us, we need to actually picture what is going on. So let's do our square field. So, okay, this looks rectangular, not a square. Okay, that's better. And then we are saying from the center, we will have some circular, because we are told that essentially the area that the sprinkler from the center, because the sprinkler is doing things like this, sprinkling the water, okay, it's doing its thing there. All right, so the sprinkler does its own thing from the center. Let's say the sprinkler is located right at the center. Now we will understand that the area that is watered is the circular area, okay? And we have to understand that basically from the center to circumference is the radius. And if we produce this, if we produce this, it becomes a diameter like that, okay? So I hope this is clear, guys. So if we let our radius, equal to x, for example, so because we know that the radii are equal, it means the dimensions of this square is going to be 2x, okay? So this is key. And essentially this is what we need to say. We can say here, let the radius of the circle. Sometimes I don't like to write a lot. Symbols make a difference. Be x. This would imply that the diameter is equal to 2x, which would mean the side of the square is also equal to 2x. So this is very important. Always attempt to set up what is necessary. And then now we need to find the area of the parts that are not essentially irrigated. So literally, the areas that will not be irrigated are these areas near the corners of the square. But it won't be easy to find the areas of those areas, right? The area of those areas. So what we need to do is to use a smart technique of elimination. So we take the area of the square, we then subtract the area of the circle, then it will leave us those areas. But remember, the question is on the fraction, meaning we need to do the ratio. So the ratio is going to be this area put together divided by the total surface area of the square, and we will be able to get our fraction. So we can say here, area of circle is going to be pi r squared. Perhaps let's just play a smart game here and not waste time here. We can say here, area not irrigated is going to be equal to the area of square minus area of circle. So always it helps to sort things out. So let's see. This is going to be s squared minus pi r squared. So the side here is 2x, and then we square that, we subtract pi into x all squared. So this becomes 4x squared minus pi x squared. Okay, so this is the area that is not irrigated. So what is our next move? We then want the fraction. We can say here then fraction not irrigated is going to be this area, 4x squared minus pi x squared divided by the total surface area, which is this one of the square. Remember, this is the total surface area that we are dealing with here. Okay, it's cutting some things here. So that's what we are dealing with. So this is going to be essentially 4x squared. Now if we simplify further here, we can see x is the common, x squared is common. So all the steps that we use in simplification, factorizations, they still apply. So we can appreciate that x squared is common to the numerator and denominator. And as a result, that will cancel out. And this leaves us 4 minus pi over 4. Do we have something like that? Option D. Okay, so we can put our answer here and say therefore the answer to this question is option D. Okay, so that was a nice question, guys. So basically it always helps to picture what this looks like. And obviously one needs to understand the given information, be able to imagine what it looks like, and put down a sketch and start working. Because all of these questions are questions that essentially demand one to do all the groundwork to the end. Okay, so let's move on. So we're going to move on to question 80. Now question 80 reads, the smaller cuboid, so a cuboid, it's a rectangular box, shown below is a scale model. So once it becomes a scale model, it means it's proportional, okay, to the larger one. All right. So if it is proportional, that means we can use the small one to find the big one and vice versa. So we are supposed to find the volume of the larger cuboid in terms of K. All right, not a big deal. So from inspection, we will see that this segment here represents the height of the bigger cuboid. And what represents the height on the smaller cuboid is that. So that means we can actually use knowledge of ratios and proportions. So this is very important. So the knowledge of ratios and proportions is key here. So let's see. We understand that essentially we want to solve the height, right? Not necessarily the height, but I mean, what we need here is the length. We also need the breadth, because volume is length times breadth times height. So we need to find these. So let's go. We know that essentially 3K is to 4 units, right? So now we want to know that L is to what? The length gives us 10. So once we get to this level, we just do cross multiplication to create an equation. So from ratios and proportion, we can work out an equation. So this implies that we multiply L by 4, it means 4L is going to be 30K. And then we divide. So we know that our L is going to be 30 divided by 4 times K. Therefore our L here, 2 goes 15 times, goes 2 times to 4. So this is our length in terms of K, using our ratios and proportion, because we know these things are proportional. Again, using the same knowledge that 3K is to 4 units. Now we want to find the breadth. So that means the breadth is to that proportion there, which is 2 units. Again, we create an equation by cross multiplying here. So these are skills that are taught in the lower grades, grade 9 to be specific. So we've got 4b equals 6K. This implies that b is going to be 6 over 4K. And we know that 2 goes 3 times to 6, and it goes basically 2 times to 4. And we've got our length. So what can we say here? We can say then volume of cuboid, the large one, is going to be length times breadth times height. The length is 15 over 2K. Multiplied by the breadth is 3 over 2K. Multiplied by 3k. This one is going to be over 1. Okay, so we sort it out. So we know that this is basically 15 times 3 by 3 is 9. K times k times k is going to be k cubed. All over 2 by 2 is 4 by 1, that's 4. Okay, now we've got to sort out that. Now again, if one doesn't really know this by heart, guys, I mean, knowing the times table is very important. But then let's just look at our long multiplication. Because this becomes our absolution here. So we've got here 15 and we're multiplying this by 9. Now this is how this works. We multiply the 9 to the 5. So 9 by 5, that's 45. So we put the 5 here, organizing it in tens, right? And then that's a remainder 4. So we carry the 4 and place it there, right? And then we say 9 times 1 is going to be essentially 9. And then we add the remainder from the previous one. So that becomes 13. So we organize this in hundreds, tens, and units. And so this is our answer. So guys, this is something very important to make sure it's in order. So if we sort this out, this becomes 135 k cubed over 4. Do we see something like that? That's option D. So we can say safely, therefore the answer to this question is again option D. So this is very important, guys, to ensure that one is clear of what to do, understanding ratios and proportions, trying to formulate equations using the technique of cross multiplication, which is a very favorite gymnastic for me, and essentially working out things step by step, piece by piece. Obviously, knowing these things is key, okay? Otherwise, problems will always be our lot if we don't know what we're supposed to do. All right, so we've got another question here. Perhaps let's just write it in the next page. 81. So 81 says, a square lawn, so this is a square lawn, has a 1 meter wide path all around it. Okay? Now we need to find the area of the lawn. Okay, if the area of the path is 40 meters squared. Again, this is yet again a question that if it is given in words, one needs to be able to imagine what this looks like. So we need to do the sketch. So let's do the sketch here. We've got a square area, right? Now we've got yet another square area around it. Because we are told here that there is a path. So the path is going to be just this width right here. If we just move like this, that's the path, and its width is 1 meter. Thick or wide, same story. So guys, understanding shapes, even reading statements enough to interpret them, cannot be overly emphasized. Because this time, the student is in charge. The examiners are just throwing stones from a distance, and the student is in charge. So remember, this is our square area. So this is our lawn, right? And this is the path. This is the path. Around our lawn, okay? Sometimes we're not sure if this is the actual sketch. We'll see if we get an answer. If we bump into an answer that is here, chances are we got it right. Okay, so this is the shape that we can have in mind. All right, so now we need to be a smart group of people. We can again say, let the side of our path, of our lawn, be x. That means all the other sides are going to be x because they are equal, isn't it? This is a square. Great. So we just simply say, let the side of lawn be x. Okay? Great. So that's all we need. Now, because we are not given much, so we need to just deal with the problem. Now what we want is, we are supposed to find this total area. So this total area of the path needs to give us answers. So we're going to organize it in this manner. So a little bit of creativity, guys, can help a lot, because now we can see that this area here is equal to that area, and that yellow area is equal to the other yellow area. So we can say here then, of course, we know that the area of the path, is equal to, now remember this is triangular, so it's going to be 2 times length times breadth, because it's that area and this area, plus 2 times length times breadth. This is essentially those green area. So this implies, we're told that this is 40 equals 2 into, now the length here becomes x. Remember, all of these are 1 meter, 1 meter, 1 meter, 1 meter. Okay, so this is going to be x plus 1 plus 1. So this is basically x plus 2, right, multiplied by 1. Okay, great. Plus, we've got 2 into, the length here is just the length of the square itself, multiplied by the breadth, which is just 1. So this implies that 40 is equal to, when we sort this out, it becomes 2x plus 4, right? Right, and then plus 2x. And then we sort this out, we will see that essentially we've got 2 plus 2, that's essentially 4. So we can say 4x equals, I'm just rearranging now, transpose this to that side, it becomes 36. And therefore our x is equal to 36 by 4 is 9. So this is 9 centimeters. Is it centimeters? No, meters. So x is 9 meters. Basically meaning the side of the square is 9 meters. You can say the side of square is equal to 9 meters. That's key. We can say here then the area of lawn is going to be s squared. Remember, this is an area of a square, which is going to be 9 this becomes 81 meters squared. Now we need to look for that answer in the options. And what do we see? Option C. Option C. So we can make a conclusion that our answer is effectively option C. So again, guys, these are higher grade questions that one need to understand by essentially imagining what this looks like, integrating knowledge by understanding again some few basics, formulae, procedures to just proceed. All right, let's not stick too much into that. Let's get to question 82. Maybe let's do it in its own page as well. So now question 82 says, a rectangular water storage tank, it is a rectangular, is 30 meters wide, right? And it's 50 meters long, that's the length, and it has a depth of 7 meters. Now what do we know? It is partly filled with water. Okay, so now it means the water level is not full. Okay, great. Now let's see, when the tank is tipped forward, this tank is tipped forward just far enough to make sure that the water completely covers the side A, B, C, D. So meaning, if we are to say this is our water level, so we can say safely this is our water level. It covers this area, A, B, C, D. Okay. This is what this is saying. Obviously, this is suggesting all of that pyramid is effectively water. Okay, so there is our water. Now, we are told here that two-thirds majority, the MK came with dreams here, pipe dreams. They wanted to win the two-thirds majority. How could they? It was ridiculous, wasn't it? Anyway, let's leave politics alone. They will win the two-thirds majority in the next elections. Now, two-thirds of the base is covered by the water. Okay? So that means the area of base here is our reference point. I would like to highlight my base here and say, look, since we are talking about the area of base, let's just highlight it nicely. Let's just highlight it. So now we know that this base effectively now got cut here into just a quarter. So can you see the bigger one is the entire one, and then the smaller one is what makes up our water level here, which is the yellow region, which is itself pyramidal. Okay. All right, okay. Now, what do we need to do, guys? It says now, how deep was the water level? How deep was the water in the tank when the base was still horizontal? So now we need to find the depth of the water when this thing was the way it was supposed to be. Now, let's just imagine the water level was over there. So we just want to work out a way of suggesting something. Say that was the water level before this was tipped over. No, not a good one. Yeah, so this was the water level before we tipped things, guys. So I hope you'll be able to differentiate the colors. So the blue is the water level before this was tipped, meaning that would be its height. So we can say height of water initially, okay, at the beginning. That is the blue, okay. Now the question is, what is the depth, which is that one right there. Now when we talk about depth, this is always in relation to the surface. So that's the question being posed, is what was the depth of the water before we tipped it over so that it looks like the yellow area. I hope you guys can still see because it's easy not to see what's going on here. Maybe let me highlight. Let me choose a color to highlight my water level. So this is our water level here. This is our water level. I hope it's not too much. This is our water level. Okay. Great. So this is our water level. I hope it's not so bad. Okay, let me try to make it nicer. This is our water level. Now this is a bad situation, I can tell you. There's a lot to consider. Okay, but I hope it's clear, guys. I'm not the guy who likes to separate things, so I like to work with what I have. But remember, we know that the corner angles, this is rectangular. So we will appreciate that, essentially. Let's look for a nicer color to use here. Yo, there's no colors that are here, man. I don't like it. Maybe let's take the brown. But now, what we want to focus on is this pyramid here. But now this pyramid is right angled, isn't it? Remember that angle is 90 degrees. Why is it 90 degrees? Because remember, this was vertical, this was horizontal. So this is 90 degrees. So it's a right angled triangle or pyramid, whatever this is. Meaning we can make this the basal side if we like, or we can even make that the basal side and this is the perpendicular side. It doesn't really matter. But the question also would be, what is this side here? We don't know that side because that dimension is important. For us to be able to use the volume here, we will need that dimension. And we have the height, which is 7, so we don't have to worry about other things. Now, this is very interesting. It's very interesting. So, guys, what do we need? We need to start here with this dimension, right? By using the area of the base and take 2/3 of it. It will give us the area of this base of our water level. Then from that area, we can work out the length because we already have its height. Or we can call it the breadth because we already have the length, okay? Then from this, we can use this smaller area now to essentially do the volume of this water, which is the yellow part. Then from the volume of the water, we can then work out what was the initial height. Because this is also a question. Then from the initial height, once we have it, we can say 7 minus the initial height. It will give us the depth, which is what we need to answer. So it's one of those questions that I call STDs. This is a higher grade question that is effectively an STD. not an infection, but this is slow them down. So this is a question that slows people down. So usually there's one or two of these kinds of questions in the exam, and one just has to deal with them. There's nothing we can do. Okay, guys. So let's start by finding this dimension right here. Okay. So I don't know what we're going to call it. Perhaps let's give it a name. Let's call it X. And we want to work it out. Now, this one is easy because we've got everything. So we know that basically area of the pyramid, let's call it that way, area of pyramid is equal to 2/3 of 2/3, it's 2/3 of the area of tank, a base of tank. Okay, that's what we were told. Now the area of the pyramid is length times breadth, so I'm just going to write these nicely, equals 2/3 into L times breadth as well. Just going to go about it systematically without rushing. See, I'm writing L and L. It's crazy. Now the breadth of the pyramid is X, so the length is 50 meters. 50 into X equals 2/3 into, now the length here is 50 still, times 30. Okay, this is nice. We're going on nicely. 50x equals, now what do we have here? This is 50. Okay, maybe let's, now by the way, this is going to be 50 by 3. That's 15, and then the zeros. So let's just move about it nicely, because we don't have a calculator, so we can't be silly here. So 5 by 3, that's 15, and then we add the zeros. So that's how I do this one. But obviously one can still do the long multiplication. Long multiplication, let's just say long multiple. So how do we do this? We say 50 times 30, and then 0 times 0 is 0, 0 by 5 is 0, and then 3, of course, before we go to 3 we put a 0, because now this is on the tens. 3 by 0 is 0, 3 by 5 is 15, so we put it in hundreds, tens, and units. So this is how one can go about it the standard way to try and avoid problems. But I have quick ways. Once things are on the tens, they're much easier, because just multiply the numbers and just keep the zeros. It's much easier that way. All right, so now what do we have to do? We've got 50x equals 2 by 1.5 is going to be 3 squared divided by 3. So this also implies that we've got 50x equals, this is just a squared. Okay, so it's much easier again. It's just 1,000, and then we divide here by 50. So 1,000 divided by 50 is what? Now we know that, okay, let me not rush before I lose you guys. At this point it's very important to deal with things nicely. So this is as good as 100 divided by 50, which we are going to have, 100 divided by 5, this is 20. But now what is this? Meters. So we know that our x is now 20 meters. So we know the breadth of our pyramid. and this would form the rectangular base, and it has a perpendicular height. So the area of a pyramid is always the area of the base multiplied by the height. Or someone can look at this as a triangle, right? Area of a triangle is base times height, right? A half base times height, because this is triangular. We can call this a triangular prism, and then we multiply by the height of 50. It really doesn't matter how one looks at it. So we want the volume of the pyramid, which is the water. So basically when we say water here, the pyramid represents water. We can say here also volume of water, which is the pyramid, is going to be, we can decide this is a triangular base multiplied by the perpendicular height, or we can just say this is a rectangular base multiplied by the perpendicular height. It really doesn't matter. So let me just choose the easier one. So it's going to be length times breadth times height. So I'm using the basal side, which is the side it's sitting on, and then CB as the height, just to make it easy. So the length here is 50. The breadth is what we just found out, it's 20. The height is basically 7 units. 7 meters. Okay, great. So this is just what we want. We want the volume of the water in totality. Now let's go on. So the volume of the water. So again, here we've got tens. So it's just as good as 5 by 2, which is basically 10. Then we bring back the zeros. Nice. And then we multiply this by 7. Nice and easy. Okay. But now, remember, I can still use the initial height of the water here. I'm just integrating now to avoid too many calculations. Initially, the volume of the water is going to be the base of the entire tank. So this is the length of the tank, which is 50, times the base of the tank, which is, the breadth of the tank, which is 30 meters, and then the height is what we want. So this is the initial height, we can say HI. So this is basically the initial volume, because the volume of water in the pyramid, it's still the same as the volume of water in the tank before we tipped it, isn't it? Yes. So again, this is 1500 HI. And then what do we do here? So integration, guys, integration. So we can see that the initial height of water here, this is 7,000 divided by 15,000. Again, this is a very easy thing to handle. The zeros pretty much take care of each other. And mistakes. This is 1500, not 15,000. So again, these take care of each other. Then we've got 70 divided by 15. Now, anyone who doesn't know how to deal with this, so we go for long division. Some questions can be a bit silly, man. So long division is basically, we are dividing 70 by 15. Or at times you can just use 5. It's not a big thing. So how do we do that? So obviously, what we are going to do here, but I think this one is crazy. Let me not even do it. Long division is not necessary. It's just not going to be a very kind thing. So here we just say 5 goes 3 times. 5 and 70 goes 14 times, isn't it? Yeah, that's just the story, man. That's just the story. So we've got 14 over 3. Let's not complicate things. We're oversimplifying maths now. Now this is meters. Okay, great. perhaps the unit should be the meters. Now we know the height of the water. So can you see, with just one step we killed two birds? Calculated the volume of the water and used this initial one. So we can say then depth of water is going to be the height of the tank minus height of water, initial height of water. Okay, maybe let me write it. Going to say height of tank minus height, initial height of water. So this is going to be 7 minus 14 over 3. And then here what we need to do is to find the common denominator, which is basically 3. Then it's just going to be 14 here. This is over 1. Then it becomes 21, right? Because it's going to be 3 by 7. So this 21 minus 14 is basically 7 over 3 meters. So that would be the depth of the water. And essentially that is option B. So it's a very nice question, very long question. So the answer here is option B. Okay, so that was an STD. Slow them down, they are too quick. That's what the person who designed this question is saying, is that, okay, these guys think maths is so easy. Let us slow them down a bit and make them work for what they want. Alright guys, so we needed to really attend to a few areas of importance in a strategic way. Okay, we needed that. So area of base of the tank was our way of going ahead using the ratio that was volunteered to us early on. And then we proceeded there by just working out things nicely, dimensions, which eventually helped us to move forward. Great. So this one was a bit of a situation, as you can see. Not a very nice question. Okay, maybe a very nice question for a student who enjoys maths and loves challenges. But a student who wants an answer and is miserable, this one is a killer. Okay. Alright guys, so that was a cool question. I'm sorry guys if I misled you, or at least you felt I'm losing you by my way of dealing with things. I'm a surgeon guys, so I work within the structures that I have. I don't like to separate things like engineers. See, engineers, they take things in parts. I don't do that. I am not able to do that. So, but this is how I was even at high school though. I never tried to draw separate diagrams to try and oversimplify things. I always liked to look at things right where they are, but find an X-ray view of vision, of just singling out the areas that I need to focus on within this complex structure. Because I always found it's better that way. Sometimes what is declared difficult, it's because it's complex in its look. But if one knows how to look in the right areas, there's a tendency to just do it easily and succeed with less effort in the future. But if you always want to separate things, then that means you'll hardly solve problems that you cannot do that, in which you cannot do that, the separation. So here's the thing. Use every other technique. I mean, do the separation technique when you can. Don't do it at some point. See how both ways work. See whether you're comfortable with either way. My opinion and my advice is try to be comfortable with both ways of looking at things, separation and not separation. Because at times You just want to choose the method that works best in a given situation. It's not always going to be don't separate. It's not always going to be separate. You understand? So that's the story. Okay, guys, let's move on. So let's go to question 83. So let's see. Question 83 says, a cube is constructed. Now, what is a cube? It's a square box. It's constructed using 64 equal smaller cubes, and the resulting solid is painted. That means we put color into it, okay? Now, how many of the smaller cubes? How many of the smaller cubes will be painted on exactly 2 faces? Yo. Okay. So this question is saying we have a cube, which is a square box that is made up of 64 equal smaller cubes, and the resulting solid is painted, meaning we just give color to it, like we have been painting things. Now it says how many smaller cubes will be painted on exactly 2 faces, meaning just 2 faces only, not all the 4 faces. Is it 12 faces? How many faces are there on a cube? 1, 2, 3, 4, 5, 6. There's 6 faces. So we just want to paint 2 of them. Okay, not a big deal. Again, guys, this needs a sketch. Without a sketch, it becomes a horrible situation. So let's do a sketch. So there is this thing here. But now I'm going to play a smart game here. And I just want to do something so that I do not find myself suffering. Sometimes it's easy to not do well when it comes to these things. So this is the story of our lives here. We've got this thing here. Okay. Just trying to construct an accurate cube here. So obviously, guys, once this is done, we can actually remove other things because they will cause us pain. Okay, so there is our lovely cube here, and then it's made up of small cubes. So let's say this is the one. Okay, so it's going to have another component here. I'm just going to try, guys. It's not so easy. Okay, so we know that there's going to be essentially a cube like that. All right. This is just trying to get something a bit closer to accuracy. So we're going to break that one out. Okay, we've got a cube, and it's made up of small little cubes as well. So this is what we need to understand and appreciate. Now, the story is saying, well, we need to find the number of cubes that actually are here. I mean, the number of cubes that can be painted on 2 faces. Now, let's just say, okay, let's let the dimension of a cube, of the smaller cube, be x. All right, so that means all of them are going to be x because they are all equal, right? So that's going to be x, 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 because all those dimensions are equal. So that's the first thing. We can just say let the side of small cubes be x. All right, so this is important. I suppose it makes life a lot easier. And this would also mean that we've got x here. I don't know why I'm just circulating here instead of moving. All right, guys, so remember, now this implies that the volume of each small cube is going to be equal to x cubed, because we know it's going to be length times breadth times height, or just side cubed. Okay, if this is the case, we also know that this would also imply that the volume of bigger cube is going to be 64 times x cubed, which is 64. I don't know why I'm even writing too many things. This is going to be 64x cubed, because we just simply multiply all of them because they are 64 and they make up this big one. So I do believe this is key. This is key. Now, this can help us to work the dimensions of the bigger cube, because we need to know what is this dimension. So if this is the case as we have put it, we can say here this implies, we know that s cubed is going to be equal to 64x cubed, which also implies that s cubed, 64 is basically 4 cubed x cubed. This implies that s cubed is basically 4x all cubed. Using our exponential equations, so we've got the same exponents, then we can equate the bases. Therefore, the side of the bigger cube is basically 4x. So this helps us to then realize that actually there's 4 of these smaller cubes here. So we will have a second one here, third one there, and then the fourth one. So this is what it means. So the side is made up of 4 little cubes. And we can actually extend this up, and this one, extend it up. Of course, it's not exactly straight. I don't really care anyway. Okay, it's going to give me a headache. So this is what we have, guys. So it's all these cubes. There are 4. So this is basically the story being given to us by our determination. So each side is made up of small cubes in that manner. So we can continue this side so that we can do the things that we need to do. Right, and then we can also see here that this must be in this manner. Okay, great. So It's not always gonna be nice, but it's gonna be closer to what we want. Some are going to appear a bit smaller, but it's only because my drawing is not drawn to scale, but it attempts to do something. Alright, so this is more or less what we have. Alright guys, so now what are we going to do? Now the question is asking, how many cubes will be painted exactly on two faces? Now if we do this, guys, let me show you this. Cubes like this here, they'll be painted on three faces. It's this face on the side, the front, and at the bottom. It's gonna get painted on three faces, and this applies to all of these ones at the corners, right? So these kinds of cubes, they get painted on three faces, basically. So I don't want to overly do this. Again, this one right here gets painted on three faces. That one over there, in fact, let's just do all of them that get painted on three faces so that there's no questions about it. And the one that drives it home is this one right here. As one can appreciate, there's three faces painted, and that means that one at the corner, although we see one face there, there's just three faces painted. Now the ones that get painted on just two faces, or we forgot to make this one also, that one gets painted on three faces, including this one. So we can just easily put a key here and say this is basically painting cube painted on two faces. Right. That's our key right here, because we can't paint all of them. Now the ones that take only two, we can see that this cube right here and this cube right here, these ones only get a paint on two faces only, this face and that face, the front and the top face. The other faces are hidden. And the same will go for this one. It's this front face and the side face, front face and the side face. This one is also front face and the side face, front face and the side face. Alright guys, just to complete it nicely, so this is what it would look like, and we can see the yellow ones are the ones that are painted on two faces only. These ones are painted on three faces, and the ones that are white, we can see that they're only painted on one face. So now the question is saying how many of the ones that are painted on two faces. We can see here we've got 1, 2, 3, 4, 5, 6, 7, 8. Of course, they will overlap onto the other side. So it's going to be these ones at the front and the ones at the back. So we've got 8 and 8. That's basically 16. And then we count these 4 in between. It's going to be 20. Right? There's 4 over here. And then there's going to be another 4 on the other side. So that's 24. So we can say then, cubes, or maybe say the number of cubes painted on two faces is going to be equal to, we can say here this is going to be 8 times 2, because it's this face and the face at the back. There's going to be 8 on each. Then there's going to be 4 on either side. Then we can say 4 times 2. That's very nice. So this gives us 24, because this is 16 plus 8. So that is 24. Now, where is that? Option B. So that is sorted. That is sorted. So, to answer the question, we know that option B is the answer. So again, guys, this is another STD. It's a slow them down type of question, because there's no doing this question in a hurry, obviously, because even to understand what is required, without a sketch, it's even difficult to figure out what exactly is this question asking. But with just a sketch and then an idea of what is going on, obviously we needed to work the side so that we can see how many small cubes make up the side. And then we work our way until we find the answer. So this is one of those questions, again, that is probably a higher grade type of question, and it's an STD. It's something that you can't just, you cannot hide. Slow them down. Okay, let's move on, guys. All right, so let's just focus on this question 87. So it says a circle passes through vertices A and D of a square, okay, and is tangential to side BC. All right, now we are told here if the square has the length of 2 meters, so this means this length over here is 2 meters. Maybe let's show it elsewhere, because we want to use this tangent. Okay, that's the story. And then now, is it even correct to say and then, as in then, ngogo, and then ngogo? Ngogo na ngogo. Crazy, isn't it? Okay, let's try and speak better. Then, what are we going to say? Well, we need to find our center of the circle. Let's say this is our center. It looks central to me. And then we want to make some constructions, right? Right. Because we want to draw a line through the center to the tangent so that these meet at right angles. Right? Because we know the tangent is perpendicular to radius. And that point of tangency, we can make it E. Okay? And then we can make our center F. Let's make our center F. Okay? And then we also want to make a construction to try and work out our radius. So these are all constructions, guys. So constructions are better done with dotted lines, because these are not necessarily what was in here. But now here's what we understand. If this line, remember this is a square, it means this side is parallel to that side. So if the angle between this line is parallel, and then we know that should also be 90 degrees. Okay? Again, these are called interior angles. They are supposed to be supplementary. So a bit of geometry that we know. But now we also know a theorem that says if a line is from the center and is drawn perpendicular to the chord, it bisects the chord. So if this is 2, so therefore this means this distance here is going to be 1 meter. Very important. So all of this pattern of thought is applying all the knowledge we know. So we are left to our own devices to deduce these. And we can clearly see that this whole length is 2. So if we make the radius x, for example, let's make the radius x and say the radius is x. Okay? So it would mean that this little portion there is going to be 2 minus x. Okay, this is very important. So what am I doing? I'm trying to drive ourselves into this triangle, because we can work with a right-angled triangle. So that shaded area gives us a right-angled triangle. So we said this is EF, we can make this one G, that point G. Now we have sorted our diagram and we can actually work with it. So let's see, 87. So we can just say here, construct EFG as shown. Obviously, if this was a question in Euclidean geometry, there would be a sketch on the answer sheet. So this would have been shown there. Right? Right. And as a result, from what we can say, we can appreciate that DG is equal to GA, which is going to be equal to 1 meter. The reason is line from center to midpoint of chord. Easy. Not to midpoint, but perpendicular to chord. Perpendicular to chord. So it bisects the chord. So that unit is important. Great. Great. The rest is very easy to follow. And then we can just simply say let radius of circle equals x, because that's all we need. All right. And then we can perhaps say here, before we say this statement, we can also say here join FA. It's important because every little bit of statement that we give, it kind of gives, the direction as to what we are about to do next. Now once we do that, we can focus on triangle. In triangle, say A, F, G. What are we going to say in that triangle? I mean, it's obviously a right-angled triangle. There's a lot of things we want to say, but first of all, in this triangle, we need to essentially prove that that is 90 degrees. I mean, we've already spoken about perpendicular stuff, so I guess we just have to leave it at that. I mean, I would have loved to say a lot of things. So what do we want? We want FA. FA squared equals FG squared plus GA squared. And we learned this from Pythagoras. All right. This implies FA is radius, isn't it? So the radii are also equal. So we know that this is going to be x all squared equals FG is basically 2 minus x, and then we are squaring that. Obviously, this is logically the case. We don't need to justify that. Then GA is 1 meter, and then we are squaring. We already justified it above, so we just keep moving. So we have x squared here equals, this is 4 minus 4x plus x squared plus 1. And then we can see here x squared is of the same sign on either side of the equation. So these ones will cancel. Then we can transpose 4x, and then 4 plus 1 is 5. We can say therefore x is equal to 5 over 4. And what can we say? We can say therefore the radius is 5 over 4. What was this? So we just told length of 2. So probably we cannot say meters, but we can just say units. Yeah. Unit there. So therefore our answer here is basically option A. Okay, great. So again, one can appreciate that it's more like proving a theorem. There has to be some construction that needs to be done, and following some justification of some sort. Obviously this is NBT, so technically no one cares how you got around the answer. The fact of the matter is that if one chose the correct answer, it means they understand the correct procedure to follow. Alright, so that is the story. And then of course, if this was a question in Euclidean geometry, remember guys, I'm not just teaching you for a specific exam per se. I'm just teaching you so that you know enough for any exam purpose, because in grade 12 one would still get higher order questions of this nature. So this can pop in question 7, question 8, in fact usually question 9. It likes to pop in as a single question, and then one can see the procedure, or it could be something similar to, it could be something, maybe word problems are not necessarily given. I doubt. Word problems are not normally given. So yeah, this one could be a question on optimization of something. So essentially this is just a way of learning maths in general, but at the same time trying to make sure that what would be important in this exam type, then at least it's covered. Okay, let's go for question 88 without wasting time. Now it says the volume of the largest possible, find the volume of the largest possible cylinder that can fit into a cube with side x centimeters. Okay, so again we need a cube here. So guys, there is our sketch here. So we can almost appreciate that technically the largest cylinder would have its circumference touching the sides of the square in both faces, and obviously spanning the entire cube in a way. So what would we know here is that essentially of great importance is the fact that if this is our center, we will appreciate that from the center to the bottom. That would be the diameter, right? And then we can make this one the radius. And essentially the radius is half the diameter. But we'll also appreciate that the length here is going to be exactly the same as the dimensions of this cube. So if we say, let the radius be r, maybe x, let's just use a familiar thing. We let the radius be r, it means this dimension is going to be 2x, right? And that also means this dimension is also 2x, because this is a cube. And that would be effectively the height of our circular prism. What were we supposed to find? A cylinder. Yes, circular prism or cylinder. So basically this is what we've got, guys. So it's very easy. So we can just say here, let the radius of circle equals x. Okay, so this means that the side of the square as well as length length of cylinder is going to be basically 2x. Okay, so this is what all of this story means. So again, having a sketch, obviously guys, you don't have to draw an accurate sketch, but I'm just trying to use the tools as best as I can so that it can be easy for me to do this at a go. Just a rough sketch for a student during the exam is, even a freehand drawing is good. It's good enough. So we want to find the volume. So we can say now then volume of cylinder. Remember, area of the circle is pi r squared times height. Great. This is going to be pi. R is x squared. Because we were told, oh my god, wait a minute. The cube side is x. Man, I'm doing my own things here. So this was volunteered, it's x. See, doing my own things is going to hurt. So that makes that one x over 2. Not a big deal. So obviously this whole story now is no longer relevant. This whole story is no longer relevant because we are given the side here. So all we can say here is that the radius of the circle is going to be a half x. Okay, so this is going to be actually x over 2 all squared times x. Perhaps we can say x over 1 because we are dealing with fractions here. So this is basically, this is pi over 1 also. So we've got pi x cubed over, this is going to be 4, right? So where do we see that? That is option D. Okay, that was not a really difficult question. Huh? I don't know why I kind of got myself scared. So we can say therefore The answer here is option D. This is the largest because, there's no way one can fit a cylinder that doesn't hug or abut the sides of that cylinder, of that cube. So this one is as easy as ABC. Let's not waste time. Once we get a simple question, we run. 89 says a rectangle ABCD. Again, the naming is important. Has AB, so let's draw our rectangle. So we've got A, B, C, D. Even if one started here and say A, B, C, D or A, B, C, D, doesn't really matter. But the naming should follow each other like that. So A, B, C, D, okay, has AB 6 units and AD, so this is 6, this is 2 units, okay? Then we need to find the area of the circle with the center at A. Okay. Passing through C, okay. Okay, we will sort it out. Okay, it looks like it almost was what I want. Okay, let's just move our dudes. Let's just move the dude a bit down. And then move our circle so that it looks like what is being proposed. Alright, so we need to just remove these letters where they are because we moved now. So this is A, B, C, D. Okay, so we know that this is the center. So this would make this the radius, right? The diameter is the radius. And essentially, we can call it R if we want. Or this is AC. Obviously, this is a rectangle, so all sides are 90 degrees, but I'm just going to focus on those two. But all of them are actually 90 degrees. Alright, so this is 6, this is 2 units. So this means we can use Pythagoras in any one of these triangles. So maybe let's choose this one. So this becomes a right-angled triangle. And obviously, we know that the opposite sides of a rectangle are essentially equal. So we don't need to stress ourselves here with a lot. So all we need is to find the area of the circle. So this is very easy. First of all, we can say here in triangle ADC, we know that essentially AC squared is equal to AD squared plus DC squared. This is from Pythagoras, so this is R squared equals 2 squared plus 6 squared. This implies that, maybe let's just move quick, we don't have time, so we can say therefore our R is the square root of, now this is 36 plus 4, that is 40. Right, and we can see here we've got some 40s, so let's keep this as it is. So we can say units. Alright, now to finish it off, just to save a bit of space, because this one is already done, so we can say now then area of circle is basically pi r squared. This is pi, r is square root 40. So this is going to be 40, so all squared. I don't know why I'm squeezing myself like this, you know. It's not allowed. So this is pi times the square root of 40 squared. So this becomes 40 pi, of course, square units. Nice. So what is our answer here? C. So this one was easy as well. It's a typical exam question, standard grade stuff, nothing really big here. Okay, so let's move on. All right, so let us move on to some more questions. Okay, we're just building up our base of knowledge. So 92 is also a question on measurement. Now we have here a circle that has the same area as the square. And you see, same area as the square with side s meters. Now we need to find the expression for the radius of the circle in terms of s. This is easy, standard grade stuff that needs very simple simultaneous equations. Alright, so we already know that the area of circle is equal to the area of square, right? That's what we are given. This implies that pi r squared is equal to, the square is side squared. So if we divide by pi, r squared is going to be s squared divided by pi. Right. Therefore our r, when we take the square root of s is just going to be s. Divided by the square root of pi. Remember, since we are not using the calculator, so we cannot and should not have decimals here. So the best answer here becomes A. So this one was a simple question. I mean, one can even include units. So we can write here that the answer here is option A. Right, easy question. Easy question. And then we look at question 94. Again, it uses structures. So let's see. The solid shown here is constructed using equal cubes, and its total volume is 189 centimeters squared. But now that can't be a volume, right? A volume is in cubic centimeters or cubic units. So this is a miss. This can't be a square. It's supposed to be cubed. But anyway, the unit doesn't really do much, but that should be a 3. Unless someone is saying the total area, which would be a different story. But then it says find its surface area, so we can't be given the surface area if we're supposed to find the surface area. So basically all of these are square centimeters, and that means this is cubic centimeters. All right, so we've got the volume, and we know that these are cubes, so this is very easy. This is very easy. How many are these, by the way? So if we can just count the number of these things, so we've got 1, 2, 3, 4, 5, 6, 7. So there's 7 of these cubes, so this is fine. So to answer 94, we are going to say, well, the area, but in any case we want the dimension here. We can just say let the dimension, or should we say let the side of each cube equal to x, right? That's what we need. And then this would imply that essentially the volume of each cube, we can just say the volume of solid is going to be equal to essentially x cubed times 7, right? So this is 7x cubed because there's 7 of these and each one is x cubed. Okay, don't know if this was written nicely, but yeah, sometimes my writing just has a way of fading away. So we've got 189 equals 7x cubed. So this implies that x cubed is basically 189 divided by 7. Now again, one doesn't have a calculator here, so long division says we've got 7 here. Oh no, space is key. This is not really the square root, right? Careful there. So we've got 189. So first of all, we just keep scanning. Can 7 go to 1? The answer is no. So we then consider the next digit. It becomes 18. So we're going to look at 18. Say 18 divided by 7, it's basically 2, right? Comma some change. So we don't worry about the comma. And then we multiply the 2 to 7, it gives us 14. And then there's always an invisible negative here. So minus 1 is 0. 8 minus 4 is going to be 4. Right? Great. And then we drop the 9. Then we say 7 to 49 goes 7 times. 7 by 7 is 49. And then obviously there's this negative that is there. 4 minus 4 is 0. 9 minus 9 is 0. So there's no remainder. So the answer is basically 27. So this implies that x cubed is equal to 27. Alright, so what do? We want each dimension here. So x cubed is equal to 3 cubed. Now same exponents, we can equate the bases. So this is 3 centimeters. Okay, so we needed to find, we were supposed to find that dimension. So we've solved it. So each one of these is 3 centimeters. So it's very important, guys, to know basics. Always. It is very important. Okay, good. Now let's move on. What do we want? We want to calculate now the total area. So now that we know that there is a total area, so we've got how many boxes? 7 boxes here. So we need to consider 7 portions of the area here. So this is very important. So, sorry. Let's look at the structure. So we've got how many faces here? 1, 2, 3, 4, and 5. So this one has 5 faces. Okay? It's the top, the side, the front, and the back. Okay? So we've got 5. And then this one, the second one here, how many faces does it have? So guys, whichever method works, but some questions are STDs. I can almost feel this is the one. It's slow them down because you can't just move fast here. Now, how many faces are we going to have here? The side, face, side, 3, and then the back, 4 faces. So there's 4 faces here. And then this one here, how many faces do we have? The front, the side, the back, that's 3, and the bottom, that's 4. Okay, it's very important to make sure this thing is on point, guys. So we've got the back, right, the side, the front, so that is 1, 2, 3, and then the bottom, that's the 4. And then this one here, number 4, how many do we have here? It's going to be the top, the front, that's 2, the bottom, that's 3, the back, that's 4. Okay, 4 faces. And then number 5, how many do we have? It's the top, the side, that's 3, the front, that's 4. That's the, 1, 2, 3, 4, 5. So it's got 5 faces to consider. And then box number 6 has how many? Now number 6 has the back, 1 face, the side, 1 face, and the bottom. So it has got 3 faces. So it's back, the side, and the bottom. So that's 3 faces here. And then the last one, how many faces will it have? So we've got the top, the side, so that's 3, 4 the front, and then 5 the bottom. So this is what we need to set up. So essentially we need to try and make this work. I just hope it works, guys. Sometimes it's horrible. So now we know that we need to consider this area in that manner. So we can just say area of solid is going to be equal to first one, there's 5 faces, right? That means 5 area, and we know each side is 3 units. So area is length times breadth. So basically it's just going to be side squared, so which is 3 squared times 5 plus the next one, 3 squared times 4. Next one, 3 squared times 4. Next one, 3 squared times 4. Plus, now let's see, how many have we added? 1, 2, 3, 4. So 1, 2, 3, 4. Okay. And then we get to the 5th one. This is basically 3 squared times 5 plus 3 squared times 3 plus 3 squared times 5. So how many are these? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So everything looks okay so far. Everything looks okay. So let's just keep going and simplify here. So this is 9 by 5, that is 45, plus 9 by 4, that's 36, plus 9 by 4, which is 36, plus 9 by 4, that's 36, plus 9 by 5, that is 45, plus 9 by 3, that is 27, plus 9 by 5, which is 45. Okay, we've got 7 numbers here. 1, 2, 3, 4, 5, 6, 7. Good. We need to keep track of things now. 45, 45, and 45 here. So this is 45 times 3. So we can do long multiplication here. Of course, guys, I'm sure probably you guys know how to do this fast, but let's just consider that person who is not as quick as all of you guys. So procedure is 3 by 5, that is 15. We put 1, we carry 1. So 3 by 4, that's 12, plus 1, that's 13. So this is 135. Right? Right. I hope that is correct. Yeah, it looks correct to me. So we've got here, maybe let's move this one before it really irritates me. Let's move it here. So we will have here 135 plus, we've got 36, 36, 36. So again, we can have here 36 times 3. Now 3 by 6, that's 18, right? Then we carry 1. 3 by 3, that's 9, plus 1, that's 10. So that is 108. Okay? Plus 27. Alright, so this is good. This is good. So obviously this was an answer from the above. This is the answer from the next one. Now all we need to do is just to take some simple addition. So we've got 135, 108, 27. Organizing this one in tens, what? So 5 plus 8, that's 13. Plus 7, that's 20. So we put 0, and then we carry 2. Then we've got 3 plus 0 plus 2, that's 5. Plus 2, that's 7. Then 1 plus 1, that's 2. So our final answer is 70. So 270. Now this is meters or centimeters squared. Okay, so this tells us that our answer here is basically A. It's option A. So that is option A. So I'm glad here we were able to apply some of the techniques that we spoke about, because it is important, guys, to master these. It is really important to master these. So this is just simple addition and subtraction, ordering things in terms of tens, units, hundreds and thousands, and so forth. So this is the story, and we just keep it moving. I don't like this box here. This box doesn't look like the way I want. It looks like the way I don't like it. So that's what I needed. So one, guys, one down, one down, one down, one down. So be capable of performing whatever is necessary to get it all in order. Okay, guys, let's move on. Okay, guys, let's pick up this question. So now the order in which some questions are going to go is not exactly the nicest, but one can appreciate that this is a question from some exemplar or some question bank or whatever. So this is perhaps another test or so. So let's have a look at it and see what this is all about. So I'm trying to find as many questions on this topic as I can. So I told you a cube, again, it's a square prism, if you will, has a surface area of a centimeter squared. Okay, surface area. Now we need to find the expression for the length S of each side of the cube in terms of A. So this is easy. So we know that a cube has got how many sides? 4 sides, or 6 faces. Let's just show. Okay, so this is a cube. It has how many faces? 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6. Yeah, it's got 6 faces. Or 6 surfaces. Just to make it easy. So again, guys, understanding these things, I'm just drawing it out so that one can see. In case one has forgotten, always rely on just doing a rough sketch to remind yourself what is going on. Now let's see. We know that, well, the total surface area is equal to A. Okay, now this implies, we know that there's 6 faces, so we're going to have 6s squared. There's 6 of them, so we can say 6s squared equals A. Then this implies that s squared is going to be A over 6. Therefore, the side is going to be equal to the square root this is going to be A over 6. Of course, how many? This is centimeters. Alright, so this is it. So, where is that answer? This is D. So that is great. So the answer here is D. Not a big deal. Not a big deal. Not a serious question otherwise. So we just keep moving. So what is the next station? Okay, let's do this question 45 quickly. Again, this is taken from NBT Prep Test 1, so one can see that. Now I told you C is the center of the circle, so that's great. And F is a point on the circle such that A, B, C, D, F is a 2 centimeter by 3 centimeter rectangle. So it's already indicated for us. What is the area of the shaded region? So again, once we have this, we need to look at this and be like, what are we dealing with here, folks? Now, a rectangle is suggesting that these angles are all 90 degrees. So this already tells us that, well, this dude is now giving us the message that, okay, this is an area of a sector. In fact, it's a quarter. It's a quarter circle. So we need to consider the area of the quarter circle and then subtract. After that, we need to subtract the area of the rectangle. So it's a very simple question, but it's a low-key higher grade in that if one does not revise properties of geometric figures, it would be elusive that this is 90 degrees over here, and it's key that that angle ACE is 90 degrees so that we can see this is a sector. Okay. Sorry, a quarter circle. So we need to find the area of a quarter of a circle. Then from that we subtract the area of this rectangle. Then it will give us the area of the shaded region. So elimination method. So all we need to do here, I'm not going to try and overly explain now. I think we already understand what is going on. So, well, what we need to say here is that angle C, let's just say ACE is equal to 90 degrees. The reason these are the corner angles of a rectangle. Don't forget, guys, something that was not really given, especially when it is of importance, it must not be ignored. Now, with this in mind, we can see here then that the area of shaded region is equal to the area of half, okay, we can just say area of a quarter circle minus area of a rectangle. I don't know, sometimes I write well, sometimes I don't. Here we Okay, at least one understands what's going on. Now a quarter of a circle is 1/4. Or you know what, the best way to do this sometimes, I mean this is a quarter circle, so okay, I'll show you what one can do if they don't realize this is a quarter circle. So this is going to be basically times pi r squared. Okay, great. Well. We have a situation. Okay, we need to cut this in half because at the same time, to find the radius, we need to move from center to circumference. And we can call that one R. So I was too quick. So we needed to solve first CF so that we can find the radius. So let's just postpone this a bit. Let's postpone this one a bit. So we can just say here in rectangle. Why do I even want a rectangle? I can just say in triangle CDF. Okay, great. All I know that this is a right angled triangle. At this point, I'm not interested in overly explaining, guys, but in an exam situation where every step needs to be shown, one needs to justify why this is a right angled triangle. But at this point, I'm not interested. So we can just easily say CF squared equals CD squared plus DF squared. This is from Pythagoras. And obviously the sides are equal and parallel to each other, so that is key. So in a diagram, show everything, guys. When the diagram is given to you, show everything that you can, because at times it's not easy to write all of this out, but if you can show them in the diagram, the person who's marking you, if they have access to the diagram as well, which is usually the case when the diagram is already volunteered, then it's easy for them to understand that the student knows their work, man. Sometimes you don't have enough time to say things, but try your best. Try your best, because you don't want to be a professional in future who is haphazard. You need to exactly mean what you say, because at the end of the day, we will have trouble understanding you. And remember, at that time, a lot is at stake: funding, money, time, all of those things, resources. So one needs to be able to put up a very clear plan so that people who need to join you in your plan can be convinced that you actually have something, even if it doesn't work out, but at least it was clear enough to convince someone to consider funding or at least investing into it. So this is building up for the future, guys. It looks very ridiculous at this point, but it's all these small things that build you up into a strong individual, okay, somebody to be reckoned with. So this is r squared equals, so essentially CD is 3 squared plus DF is 2 squared. So 3 squared is 9 plus 2 squared, that's 4. 9 plus 4, this is 13. So we can say therefore our r is basically the square root of 13. And this is in centimeters. Okay, great. Now we have our r. We can then put up the statement where it belongs. So this is fine. So here we can just introduce a very simple English word and say also. We understand that ACE is 90 degrees. These are corner angles of a rectangle. Therefore, the area of the shaded area is going to be as we can see it now. So this is basically length times breadth. This is 1/4 of pi. Now r here is basically square root of 13 squared minus the length here is 3 times 2. So what is the answer here? So this is basically 13 pi over 4 minus 6. Do we have something like that? Option C. So this is very easy, so we can say therefore here answer is option C. So guys, a little bit of planning and some basic formulae need to be understood to really deal with these questions effectively. As one can see, this is not a difficult question. It's more what one can call it, both standard grade and higher grade included. Now, if one didn't know, because let's say the angle is not 90 degrees. Now with the angle being 90 degrees, we know that we can say the area of a circle is going to be pi r squared multiplied by the ratio of that angle, which is 90 degrees, divided by the ratio of the full revolution, because this is a point. This is 360 degrees. Okay? And then, obviously, we can do gymnastics. The zeros go. So 9 once to 36 4 times, isn't it? So this is how that quarter came about. So this is pi r squared times a quarter, which is what we call a quarter circle. So this is something to think about. So sometimes the angle can be 20 degrees, it can be 30 degrees. The one thing that one needs to realize is that that portion of the area is going to depend on the ratio of the angle inside as opposed to the entire revolution, which is 360. And this gives us the ratio of the sector of that circle that we are dealing with. So I hope this one is also clear in case one doesn't understand, especially when the angle is not 90 degrees, what to do. So just the ratio of that particular angle and the revolution, and then multiplied by the area of that circle. It will give us the proportion of that area that we're looking at, that sector. Okay. Easy. So that's the most important, I suppose. It's key because as one goes along, one may actually encounter a question that doesn't have a 90 degrees and then get stuck. All right. Otherwise, common things almost always occur commonly, so know them by heart. Then whatever is not so common, deal with it whichever way is convenient at the time. Okay guys, so we move on to the next few questions. Again, one can see this is NBT Prep 2. Okay, so this is 57. All right, so let's get a look into this question and sort it out. So we are told here that the diagram shows a right-angled triangle ABC. So ABC, obviously these are acute angles, so this is already suggesting that this angle here is 90 degrees if it is right-angled. But be careful, sometimes how it looks is not exactly what is being sent to us. So a question in maths, sometimes if it is not clearly stated, be very careful of just jumping into conclusions by the look. Remember, these diagrams are not necessarily drawn to scale, so you may find what looks like a right angle, it's actually an obtuse angle or an acute angle. It really matters to be very, 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 very slow to jumping into conclusions. So I could be wrong here, but let's read on to see if this is correct. Now, with lengths AC, okay, and CB, okay, like that, okay, so there's A and B, fine. Now we're told you find the ratio of the area of the inscribed square. Can you see? Now that this is an inscribed square, this already suggests that now I definitely am correct, because the corner angles in a square are 90 degrees. Okay, and most importantly, one could easily and fully appreciate that this side is parallel to the other side, not just parallel but equal to it, and this one is parallel to the other one, and not just parallel but equal to it. So all these little pieces of information, guys, cannot be ignored, because they are usually the main keys to cracking the questions, because it's all about these little things that no one revises. Remember, you don't know exactly if you will need this or not, but to highlight it in your mind as you go through the question, sometimes you may realize that it actually serves you right into the idea you need to get to the question, because if that is not something that is made aware in your mind as you look at this particular question, then you start to cry and say, I don't know how to go now. So revising a few things is not a waste of time, but don't overly do it. That's just the problem. Always find a balance. When you feel like you're going deeper now into something, then it means you're getting lost. That is just the idea. So a quick look is okay. Then if the question doesn't get solved still, then a deeper look. But don't always exhaust all possibilities, but try to revise the quicker things that are obvious, because it's one of those that is going to work. Anyway, let's have a look at the question. So we need to find the ratio of the, again, see, we need to find the ratio of the area of the inscribed square to the area of the triangle ABC in terms of A and B. Okay, now this is definitely one of those silly questions, higher grade, and it's an STD. Yay. Yeah, this one, slow them down. Anyway, let's see, what are we going to do, guys? We can clearly see that this whole side is B, and we clearly see that this whole side is A. All right, so now the question is, what is this side? What is this side? Okay, so now that becomes a bit of a situation, I'm telling you, because now we end up in trouble. So we've got A, B, C. Let's call this portion D, and say E, and say F here, so that we can be able to identify structures. But now guys, look at this. Side drawn parallel to one side. Now, aren't we looking at some proportionality theorem here? It looks like it. It looks like it. Some proportionality theorem is definitely at play. Okay, so that's fine. That's fine. So what are we going to do now? Because we need to do some things, but now these things are a little bit horrible. But now what I'm going to do, guys, I will say to us, look, we are smart people. We can make the side of the square equal to x. So if we let the side of the square equal to x, we know everything else is x on the square. All right? That makes life a lot easier. But of importance, we will appreciate that here we've got two triangles that are similar. How do we know? It's because we appreciate that this angle here is equal to that angle. These are corresponding angles with these two sides that are parallel. Again, that angle here is 90 degrees, right? I mean, these are angles on a straight line, and then again here 90 degrees, angles on a straight line. So essentially, those two angles are also equal, right? In a way. And then we also know and appreciate the fact that this angle here is equal to that angle. These are again corresponding angles with DE parallel to CB. So we can see that these definitely are similar triangles. So we can use the issue of similar triangles because, well, proportionality theorem could work, but I'm not too sure how. But from what I can see here, similarity of these two triangles would work in our favor to try and figure out what could be this side, essentially, and against this side. We can work something there, I do believe. Because using these two triangles, we can actually solve for x in terms of A and B. The main reason for us to use this is because we want to solve for x in terms of A and B. So a little bit of planning is always going to take us, a long way. So again, guys, to avoid saying a lot of things, I think I have explained exactly what I'm doing on the diagram. Obviously, if this was an exam where this question was standalone in the standard examinations, all of these steps need to be justified. But the good thing is a diagram is always provided. So just annotating the diagram is good enough. And then one needs to prove similarity of these triangles. Then after proving the similarity of the triangles, use the sides in proportion to work out a particular ratio. But at this point, I am not going to waste my time doing that because this video is going to be longer than it's supposed to be. So we can focus in, or maybe let's just say a few things. We can say let x be, or let's just say let the side of square equal to x. All right, so it always helps sometimes to choose a variable that one can just use easily. All right, so all we need to do here, we can say now in triangle, say ADE. Of course, one would have shown those. And triangle, what is this? okay, let's say BEF. All right. So what are we going to say in those triangles? Okay, guys, we know these are similar. I'm not going to explain that. I'm just going to use the sides in proportion. But I want to carefully select sides that do not include a side I don't know. For example, I don't want AE because I don't know AE. I also want to avoid EB. But I want something that is going to be common to this square and to this side CB. And that would mean FB and AD. So this is what is important. Now, guys, we can just pick and choose whatever we want. From what I can see, if I'm looking at this triangle ADE, I look at AD. I know that AD over, now AD is opposite that angle. That angle is equal to that in this other one, and the side opposite is EF. Is equal to, now I want to use a side that I know, DE. Over, now DE is opposite that angle, which is equal to that, and the side opposite that is FB. So here I'm just going to say proportional sides of similar triangles. I'm just suggesting that these two are similar because they are equiangular. Obviously, this would have been a proof because sometimes it carries marks. At this point, I'm just moving fast. So now, guys, we just substitute. So AD, remember we said this is X and the whole side is B, so AD is going to be B minus X over, and then we've got EF. EF is just X equals, then DE is X over FB is basically A minus X. Okay, great. So here we just do our famous gymnastic cross multiplication. So we can just say X squared is equal to, then these ones are going to multiply. So we've got B minus X into A minus X. Okay, great. So now our task is to FOIL. X squared equals, this is going to be AB, okay, then minus BX minus AX plus X squared. And then we can see here X squared is equal to X squared. So these ones will cancel out because as we transpose one side to the other, it basically disappears. So what we have here now, it's basically 0 is equal to AB. Now we can take out the common factor here. You can see that basically here, AX and BX have a common factor here. So let me see, what are we going to do now? Maybe let's just do this. Let's just transpose this too. We transpose this to the other side. It's going to be AX plus BX. Okay, they become positive. They are each going to be equal to AB. And then we can then take out the common factor, which is X. Then we've got A plus B equals AB. Therefore, we wanted to solve X in terms of AB, or A and B. So this is going to be AB over A plus B. So, can you see, guys, proportionality theorem, but coming in a way that one wouldn't think about it, because it's so easy to miss this and feel like this is me getting stuck. So one can clearly see AB is there, AB is there, AB, AB. Then there's some A plus B or B minus 1, whatever. So obviously A, C, and D look like candidates We're not sure about B, but just looking at this, not so complete an answer. So maths, guys, remains maths. I cannot overemphasize that. Anyway, now we want to then use the original triangle ABC and this square now, because we've got its sides just the way we know how. All right, okay, all right. So we can say here then, we want the ratio, right? So we can say area of square, because that's what we want, divided by area of triangle is going to be, now remember, this is side squared. So this is basically going to be AB over A plus B. Remember, the side is squared. So instead of that line, we just extend it, divided by half. The base, we can use A if we like. And then the height, we can use B, because it's half base times height, isn't it? So now when we square this, this is basically, let me see. Jesus is alive. Yo. Jesus is alive, afterwards. So this is going to be basically, let's just say AB squared over, now this is going to be A plus B all squared. We can change this. This is going to be AB over 2, so this is going to be 2 over AB. Okay, now we can see here that we've got AB, so those dudes, this one will just take the square, and then the rest, numerators multiply, denominators multiply. So our answer is basically 2AB over A plus B all squared. So what does that look like? D. So this becomes our answer. Okay, so that is it, guys. So we can say here, therefore our answer here is option D. So this is one of those questions, again, that is not so nice. It's not so nice. But if one understands what is important and understands what is given and some actions of naming certain things, something, and then solve for that something, because we just want to use it as a means to an end. It's not an end in itself. So that's why we introduced it and then eliminated it, because we just wanted to bring in what was given already. So I hope this is clear, guys, and I cannot say more. Again, this is one of those questions, higher grade stuff, essentially low-key killer. This is a low-key killer. So let's have a look at this 59. I think this is also a good question. So let's look at this one, question 59. So in here, what are we given? The diagram shows 3 circles, okay, each with a radius of 2 centimeters. So this is important. Now the circles touch each other so that at each point of contact, 2 of the circles have a common tangent. This is another key information. All right, so we can see here, if we were to draw a tangent through here, 2 of them would have a common tangent. If we draw it like this, 2 of them would have a common tangent. If we draw it like that, 2 of them would have a common tangent, while the tangent becomes a second to the third circle. Okay, so that is the image being propelled here. Now we need to find the area of the shaded region enclosed by the 3 circle discs. Now again, this is another higher grade question, guys, unfortunately, and it's of the order of the STD. Slow them down. Let me drink my coffee quickly. Yeah, it is so nice. Please guys, don't drink coffee. It's dangerous, okay? Drink it once in the morning. Don't do what I'm doing. Problem is that I'm hungry, but I cannot sit down and eat now. I need to finish this thing. So let's rush through it quickly. Very nice. Okay guys, at least let's target 3 hours. If I reach the 3rd hour here, I'm gonna have to cut the video, even if I have not finished the questions that I think we should demonstrate here. So let's go. So now we need to be as crafty as ever. So we know that we've got a circle centered also, circle centered also, circle centered also, and we know that this is 2 and it goes on to 2. 2, 2. So we need to be conveniently drawing our radius so that they overlap, okay? It makes life a lot easier. And we know that this radius here is 2, and that radius there is 2, and all the others. So what does this become? An equilateral triangle. So what we can appreciate is that we end up with an equilateral triangle, essentially. Now, this is already saying this angle here is 60 degrees, because that is an angle in an equilateral triangle. The angle is 60 degrees, and they will all be the same, 60 degrees, because the sum is 180. So an equilateral triangle is a triangle that has basically 3 equal sides and 3 equal angles, and those angles become 60 degrees. So this is what we have, guys. So now we can clearly see that, well. If we focus on this one, can you see this sector here? This sector is made up of 60 degrees, and it should be equal to that sector, obviously. And it should also be equal to that sector. And we can calculate those areas. And that means we can calculate the area of the triangle and then subtract the areas of these sectors here. Then it will give us the shaded area. So this is easy, guys. Obviously, it's a higher grade question. It's a low-key killer. But if one can look and see what is going on, it's nicer. Someone may even decide that, let me introduce my tangent as well. Say, look, if I decide to draw a tangent through the center of the other circle, in between those two, then I will have 90 degrees here. Isn't it? So I can easily use this area and say that is the base, and then this is the height, and then that is the hypotenuse. So I know that these two triangles are congruent. So if I calculate the area of one triangle, I then multiply it by 2 to get the area of the bigger triangle, and then essentially calculate the area of these sectors here, and they are equal because they are all the same proportion, 60 out of 360 of a circle, because these circles are also equal, or they are congruent. If you put one circle on top of the other, you won't see the others. So one has 2 options here: to use the area rule using the angle 60 degrees, but if they forgot to use the tangent, just area base times height, and then use. But in any case, this 60 degrees is necessary because its absence leaves one crying. Alright, so I'm not going to use the area half base times height. I'm a bit tired now. So one can use that approach, but I'm just going to use the area rule here, just to make you appreciate trigonometry as well. Okay, so let's move through this question nicely. We do not have anything to tell here, guys. I'm just gonna base everything I'm doing on the sketch now. I'm not interested in overly explaining. I think we've lost enough time. So what we are going to say here is that, let me just write here from the diagram. Obviously, sometimes when you are tired of saying a lot of things, there are many ways. So guys, I'm just trying to show you the flexibility you need to display when really giving answers to your examiners or your teachers, so that they just don't have a choice but to like you, even if they didn't like you at first, but they just have to love how you see things, you know. We cannot be clapping hands for people who just reproduce and regurgitate. We want people, man, who just show that, you know what, I may not get it right, but man, it's just one of those days where you cannot just get everything right. But give this thing again, I'm taking it down. Or give me something similar, I'm gonna kill it and nail it on the wall. So it's the story. So obviously when one is tired of saying a lot of things, just say from the diagram. Already one has indicated that these sides are equal and all the angles are equal. So my life is just as simple as ever. What am I gonna say? I want the area of the shaded area. So I'm just going to say area of shaded area is equal to the area of the triangle minus the area of the sectors of the circle. Okay, maybe of circles. Sectors of circles. Nice. Okay, so we've set up the mode just right. Now this is half sum of the two adjacent sides. So this is basically 4, because it's 2 plus 2. So this is 4 times 4 sine of 60 degrees, because sine of the included angle, minus. Now these sectors, they are all equal areas, so there are 3 of them, 1, 2, 3. So this is going to be 3 times pi. Now r, the good thing is that we know the radius is 2. So this is basically pi into 2 squared times, now this is 60 degrees. Now we don't know, so this is going to be 60 degrees. So we're going to multiply this by 60 degrees over 360 degrees, because that is how we get exactly the proportion of those sectors. So I've shown you guys this thing above, so I'm sure this does not scare you. I was showing it deliberately because I knew one way or another, somewhere in our walks, we will find it. Okay guys, so this is cool. Sorry, this is basically half of 16, so this is 8. Sine 60 is root 3 over 2 from special angles. Okay, that's if one knows trigonometry, but if it's lost, then use half base times height by first finding that height using Pythagoras theorem, because we know the hypotenuse is 4, we know the side is 2, then we work out that side by saying square on the hypotenuse minus that square gives us that side. Then do that, because sometimes it gets to that. But this is the most important one, because there's no running away from it. Okay guys, let's just simplify this a bit. But now when we simplify this, we can simplify it into a round bracket. So basically this is 4 pi. Okay, times. Now we can do the same gymnastics that we've been doing. That and that takes each other out of the game. So we've got 6 over 36. So this is basically 1 over 6. So this is 1/6 of a circle. Interesting. Interesting. I am telling you. So again, here 2 goes once, goes 4 times. So we get 4 root 3 minus. Now this is 3 into, we have not finished here. 2 goes how many times? 3 goes, oops. 2 goes 3 times, goes 2 times. Nice and easy. And then eventually we will see that 3 and that 3 disappear. Holy cross. Now I just moved faster than I was supposed to. But anyway, it's okay. So this is basically now 2 pi. This is this one. This is this one. Option C. So we can say here, therefore, the answer here is C. Alright guys, so I moved a bit quicker, but I mean, it's okay. Sometimes it gets boring to just keep prolonging the inevitable. We just move on. If you don't get that one, we chop them and pull them. That's it. So by the way guys, explore using the half base times height on the bigger triangle. And obviously one would need an intermediate step. That's why I avoided that one, because one needs to first find that height using Pythagoras and then use the area rule. So it's going to at least increase the steps. But either way, please try and explore it, because at times that technique may just be the only technique to solve a particular problem. So ignoring it now just because there's another option is not good enough. Okay, let me just try to write this nicely so that it's easy. All right, so that is the story, guys. Let's move on. So guys, I would like to close up our discussion for the day with these questions from the exemplar. Okay, so this one is downloadable on the internet from the NBT website. So this is the nicer ones. Obviously, that exemplar is also given with answers, I guess. So I'm just trying to, to be as complete as I can be. So let's just move on to this question 8 from the exemplar. What is the story about this question 8? It says, suppose ABCD is a square. Can you see? ABCD is a square. Okay, and with the length x minus 1 centimeters. Okay, so since we know that if this is a square, all the sides are equal, so we don't need to show that. Okay, now we're told here that if the area of the rectangle ABFE, the entire rectangle, so this is essentially the entire rectangle, is given by this expression. Okay, then what is the story? Then the length of FC. So the question is on FC or CF. Then FC in centimeters is it 4, is it 3, is it 2, is it 3, is it 4, is it 5? Okay, so this one is a very simple question, honestly speaking, because we just need to find the entire side BF, right? And then from BF we subtract this, then we'll find CF. Okay, so our key to this fight is to just find BF. in this whole business. All right, let's have a look here. What are we going to say? We can say here area of ABFC. Is it ABFE, not C? ABFE is equal to length times breadth, because this is a rectangle. Now, this is going to be equal to, remember this side is also equal to that side, which becomes the breadth, but the length is essentially BF. So we want to use BF to our advantage. So we can just write BF into x minus 1, because this would be the breadth. Easy. But now we are given that this area is itself x squared plus x minus 2. So essentially there's no need for the bracket. Okay, that's what we are given. All right guys, so let's just go about our business easily. So we can see here, this implies that our BF is going to be equal to x squared plus x minus 2 divided by x minus 1. Okay, so we move on. Now we can factorize that thing into x minus 1 into x plus 2. So again, algebra, and we can see this is a common factor. So those two divide out and become invisible. So we can appreciate that BF is going to be x plus 2. But then BF is made up of C. In fact, let's not even waste time here. This implies that BF is, which also implies now BF is made up of BC. BC is basically x minus 1 plus CF, which is what we want, is equal to x plus 2. And already here we can appreciate that x and x are the same on either side of our equation, so they will essentially disappear as we transpose. So we can make a conclusion therefore that our CF is equal to, transpose this, it becomes 3 centimeters. Therefore our answer is B. Okay, nice and easy guys, nice and easy. So this was a bit of a nice question, typical of an exam question, to be honest, because yeah, you get these kinds, and again this one, both standard and higher grade. It's not really higher grade, but it's not exactly standard, is it? Yeah. Anyway guys, so let's just finish up now. So let's end with this question 9 of the exemplar and work it out. Obviously guys, I'm going to attach these in the I'm gonna have all these questions attached to this memo, and this memo will be available for download. So check the description and you can download this memo for future reference, and also to try and aid in studying, because remember, as much as there are no notes in maths, but at least this memo is as good as the video. So sometimes you may not have data to go and watch the video again, so you can use these notes as a reference. But I would advise though, don't skip the video and target the downloading of this, because you will have problems. Certain things that I have said may be lost, and then find yourself going around in circles. Okay, so all of this memo is going to be available guys in PDF. So you see, ngiyanizama ndinizamile nina ningazodlala lapha nangona nje ningandi support izibhani akunandaba. It's all right, it's okay. I didn't open this channel for that. I just wanted to help anyone who bumps into this, and especially in South Africa, because yeah, we know the problems in our country, guys. The teaching is uneven, it's unequal, and it's not because of race or whatever. Please, anyone who has those ideas must just disappear from the face of the earth. We don't need such energy. It's not because of racial issues. There's no racial issues that can make education uneven. It's just us. You know, I would say us because we are the ones who should be supporting each other. In fact, when I say each other, all of us, meaning blacks, whites, Indians, coloreds, you name them, we should be giving each other a hand and to make each other a better version of ourselves as a rainbow nation. Yes, we will fight. Human beings always do. They can make each other monsters of each other, even based on race or whatever. It's something we can never get rid of. And we should not really be crying about it, because what does it help? Nothing. We will always be human beings who will at some point look at each other and fight. At some point we'll look at each other and support each other and be in solidarity and fight a common problem to win a common goal. Sometimes we're going to disagree and separate. Sometimes we're going to essentially avoid each other. Sometimes we're going to speak ill of each other. What does it matter? Nothing. So all you need to do is to just do things that benefit all of us, and hopefully, we will get to our near future and get to see the fruits of our hard work. Obviously, guys, this is just my wish that we can all just focus on the common goal to improve ourselves and our nation as a result, and that's what matters. The rest is never going to stop being present, but we can neutralize it by not focusing on it. Because trust me, anything that is not given attention pretty much disappears on its own without any effort from those who would want to essentially waste time trying to get rid of something that probably not gonna go away unless we just ignore it. Because ignoring it would make it disappear, you see. I mean, if I want to spite you and you don't really budge, you don't give me the satisfaction, do you think I'm going to continue spiting you? No, I won't. If I bully you and you just give me no attention, in fact, it doesn't seem like it's doing anything, do you think I will have all the energy? Because remember, the motivation for someone to keep mistreating you and treating you badly and, you know, putting you in some tight corners where you don't know where to go, it's when you show that you're uncomfortable in those corners that they put you. And then that's motivation for them. Even sometimes fighting it literally gives them motivation, because they're like, okay, you think you've got strength? Let's test your strength. So at the end of the day, there's no point in engaging in unnecessary warfare and unnecessary fights and trying to undo what is already present and it's the way it is. All we can do, guys, is to educate ourselves, not necessarily to compete against each other, but to just to do good where we are. You see where I'm standing? I'm giving you guys a lesson. I hope that is making a difference here and there. It's okay, it's not going to be the entire country, obviously, but some students who bump into these videos will probably benefit a thing or two, and they bounce onto some other person's channel, then they benefit, and that's how it is. Where one is must make a difference right around them, and if it happens to hit even far from where they are, that's also good, because at the end of the day, we need to spread the fire of unity and progress, not the fire of destruction and hatred. Anyway, guys, I'm talking nonsense because I'm at the end of my video, and in fact I planned for 3 hours, so I'm almost at the 3rd hour. So let's just move quickly and finish this thing before that hour anyway. Now the figure represents an empty cube. So what is a cube again? It's a square prism with a circular opening at the top, so we can see that. So the diameter of the opening is half the length of the diagonal AB. Okay, so the diameter, if we are to draw the diameter AB here, and we are told that the diameter of this is half AB. Okay, yeah, that is pretty interesting. So maybe let's show it this way. So the diameter here is half AB. That's what we're getting. That's very important. And then the outer surface area of the cube in square centimeters is. Okay, great. So here's the most important, guys. This is a cube, right? Right. So a cube is basically going to have this side, which one should I choose? And then this side, right? These ones are at right angles to each other, right? Because this is a cube, so this is 90 degrees. Forget that circular part for now. So if this is 90 degrees, we can actually calculate the area, the length of AB. And mind you, we're given that this is 8 centimeters. So we know that in a cube, all sides are equal. All right? So that is the story that we know. So all the sides are equal because it's a cube. So literally, we know the dimensions of this thing here. So we can find AB using Pythagoras. And then from Pythagoras, we can actually find this diameter, because that diameter is half of AB. And from that diameter, we can use that to find the radius of this circle from its center over here. Then we can use the area of this circle. Remember, the surface area at the top is going to be the total area of that face of the cube minus the area of that opening there, which is circular. So we'll need to consider the entire area. So once you subtract that, we will have the area of the top, and then of course we have the normal faces, 1, 2, 3, 4, and 5. Then that 6th one, we know that it's not complete, so we'll have to subtract something from it. Or we can easily just say all 6 faces, then subtract the area of that circle. So it makes life a lot easier. So planning, guys, and understanding the diagram helps a lot, because then the procedure becomes easy. So then we'll pick out what is the answer here. Okay, first of all, we need to find AB so that we can find the radius of the circle. So we can just say AB squared is going to be A squared plus A squared. Of course, this is from the diagram. At some point, if one annotates the diagram from the diagram. So what I mean by the diagram, I mean the one that I annotated. Obviously, in the questions below, I will not have these annotations included, but one would have to use the video to annotate those diagrams again. All right. From the diagram, I know that AB squared is going to be equal to A squared plus A squared. This is from Pythagoras. Obviously, I've indicated the right angle, I've indicated the sides, so I don't need to be saying more. So this, therefore, tells me that AB is equal to 2A squared. Sorry, AB squared. Implies that AB squared, therefore AB is basically the square root of 2A squared, which is A root 2. This is centimeters. Great. So we needed to find AB. But now we know that half of AB is the diameter of the circle, right? We can say but diameter of the circular opening is equal to half the radius of AB, the size of AB. Okay, that was given. Plus, now diameter is 2 times the radius, is equal to, this is half, AB is basically a square root 2. Okay, so we then divide by 2, therefore we can see that R is going to be a quarter of a root 2, or we can even just put it as a root, we can just write it as a root 2 over 4. Okay, so this is as good as what it is, because we know we needed to find. So can you see, guys, when your maths is on point, it just flows. It just flows. So sometimes multiple equations can be avoided if one can just integrate information properly. Now let's finish, guys. So we want to find now the total surface area. We can say then the surface area of cube with the opening, remember? We can say then total surface area of cube is equal to, now it's all these 6 faces, right? So it's 6 s squared. In fact, s, okay, let me just write the formula, minus the area of the circle. So this is 6. Now the side is a, and then we square that, minus area of the circle is pi r squared. I don't know why I'm even writing that. What is our r here is a square root 2 over 4. And then we are squaring. So this is 6a squared minus, now once you square this, the 2 is free, right? But the 4 goes to 16. So we're going to have here basically 2 pi a squared over 16. And then gymnastics, 2 goes once, goes 8 times. And then we keep going. So this is going to be 6a squared minus basically pi a squared over 8. So where is that one? Is C. So our answer here is C. Alright, guys, so this is essentially how we sign out. The answer is C. Alright, guys, so I hope you enjoyed the video, and I will see you some other time. I hope Miss Abrahams, you enjoyed the video, and of course, if I did not fully answer some of your questions and necessities, you can just point me in the right direction by just perhaps emailing me some of the direct questions. You can just check on the description of the channel itself. I have my email address there, so you can email me those questions you probably need, or at least direct me to a resource where I can find some of those questions that you need, and hopefully everything is fine. Otherwise, anybody else who's watching and enjoys these videos, just leave a thumbs up, guys. Then you can wave your goodbyes nicely. Otherwise, have a good one. I'll see you some other time. Bye-bye.